famous Serbian inventor Nikola Tesla in 1893 lit up the whole Chicago Fair and that way introduced his alternating system of generation, distribution, and utilization of alternating current. And this way he lit up the whole world. At that demonstration, he also used the so very famous Columbus X experiment. He was, very much a showman to try to show in a very convincing way of his rotating magnetic field that he generated his polyphase currents and used them to turn the metal egg around and going from eventually like circling around with no visible force. Actually, this here is a party type trick to demonstrate his rotating magnetic field. As you can see on the left-hand side is actually 1 horsepower industrial-made induction motor, which is called induction motor with a squirrel cage. But at that time, they all didn't call him initially they called him Tesla motor, but later they wanted to downgrade his importance. They call it induction motor with a squirrel cage. Now, the squirrel cage was a rotor, which is much heavier, but here what we have taken, we took the rotor and put out any metal object. In this case, it is a Coke can, which, as you will show, it can rotate just simply by turning the switch on, and now you see this Coke can rotates. It's a little bit unbalanced, so that's why you hear the noise. Of course, in order to make this work at 1 horsepower, or roughly kilowatts, 750 watts, what we needed, and you can see here also that this induction motor has what is no connection to the rotor to bring the power to the rotor, which is what is needed in a synchronous motor, but it has its own ability to start from zero with large torque, and that is the reason why most of the electric power in the world used as a motor are using his induction motor, and most of the power generated is using his synchronous generator, where instead of this rotor, like Coke can, which has no power brought to it, it has essentially electromagnet, or in a simpler form, having simply the permanent magnet. In fact, most of the motors nowadays, because they are more efficient, they use a synchronous motor, which is also his invention. Here, what I demonstrate, you cannot really operate this induction motor with a Coke can inside, because once you take this rotor out, you make very low inductance, and it will be huge current which will burn the stator winding. So what we had is in a box on the right. You see the box has a two-fold objective. One is to reduce the voltage from regular 110 volts, as you see the plug bringing the regular 110 volt alternating current and voltage into system. But on the output of this box, we actually reduce the voltage from 110 volts down to 10 volts. That means by reduction of the voltage by 10 times, the torque or a force on it, on the rotor, is reduced voltage times square, which is 100 times. That's why it doesn't take much torque to turn this one on, and therefore this Coke can turn on. You also saw that this one does have a very good starting torque, because you can just turn it on and it'll start with the full force from the very beginning until it almost approaches close to the synchronous speed for a 60 hertz operation. That is 3,600 revolution per minute, but that is basically 3,550 or so would be typically what would be actually running speed of this squirrel cage rotor. Another objective is needed. This is what is needed to operate the motor is and make it this rotating magnetic field by using those two stator windings. We needed a two-phase power, which means two sinusoidal voltage waveforms which are shifted by 90 degrees from each other. What is done here, this box has a double duty because inside the box we use the regular utility power, as you see coming with the cord, but on the output on the other side, we generated a two-phase system. How did we do that? Well, we faked it and make a almost a good second-phase system by using the same utility line and put a capacitor in series with it, rather large capacitor, which will convert the current to make it 90 degrees, close to 90 degrees shifted out of the primary generating utility power. So therefore, we have, as you can see on the back, we are feeding the induction motor with this two-phase system, and that's why we create a stator rotating magnetic field, and it works as similar. So it's a real-life demonstration of induction motor, its principle and a big advantage. And this is his way that for first time he was able to demonstrate that alternating current and alternating voltage is a way to go, because before that Faraday invented electromagnetic induction law. However, he essentially didn't realize the advantages of, in fact, they all thought that this alternating current is useless because they couldn't use it. They had to use some kind of mechanical commutator rectifiers to generate out of this useless, what they thought at the time, alternating current and voltage to rectify it to make it operate DC and then use it to drive the various loads. Now, the same thing as both Faraday passed away several years before Tesla was born, and actually in 1852, when Tesla was born, he invented the rotating magnetic field, demonstrated in Budapest in 1882, and unfortunately, great James Clerk Maxwell died some 3 years before that in 1879. My claim is that if both of them were alive and were able to see what Tesla did with the alternating power, which was considered by both of them useless, that it would hail him as perhaps one of the greatest inventors that the world has ever seen. Okay, so let me now show again close demonstration. So we turn on the power, and now two-phase rotating magnetic field generates without any mechanical connection to the rotor. As you can see, you can put any metal object and it will rotate inside the induction motor. Beauty of that is that without people realizing, this is a genius of Tesla, because you could put, instead of cocaine, you could put electromagnet, in other words, on a piece of ferromagnetic materials, conducting materials. You can put a wire and create electromagnet, which is really to emulate the but in that case you have to bring the power to the rotor, and typically what's used the DC power to bring that to the electromagnet, to the windings, and that way it cannot operate on its own. The beauty of that invention is that you can make an electromagnet and make it a synchronous motor by bringing external power to make it like an electromagnet. However, his beauty is that he showed that you can short circuit the secondary, which is really what it is, this electromagnet with a winding on a secondary, and then create even better motor than it can be done with the synchronous motor. So therefore, clearly what he uses here, transformer action, in addition to rotating magnetic field, there is from 3 stator windings, or 2 stator windings in this case, or a 2-phase motor. You create a rotating magnetic field, and rotating magnetic field miraculously creating a secondary, which is shorted circuit, also a rotating magnetic field, which actually is pushed by a primary and with a little lag, which is called a slip. That's why induction motor could never reach the synchronous speed of 3,600 RPM, but it's coming close to, 3,500, and this difference is called a slip. And of course has all the advantages, so there are 2 inventions in it, not only his polyphase currents and creating a primary rotating magnetic field, but they also create the secondary rotating magnetic fields, and in short return secondary, that secondary stator field interacts with the primary secondary rotor field, rotating field interacts with the primary to create the motion. That's a beautiful, beautiful demonstration of his rotating magnetic field and his introduction of alternating power to the world that we still use today, some 200 years after the invention of the electromagnetism in 1820 by Ørsted, showing that electricity and magnetism are connected. Thank you very much, and all thanks to Nikola Tesla, we now still use this system as until now unsurpassed. However, there is a possibility on the way that we can supplant his alternating AC system with the new revolutionary type of the DC high voltage transmission system. Thank you very much for your attention.